formula is known as the Rutherford scattering formula. Okay. Okay, I am going to erase this here. Okay. Okay. Now, I will relate this a little bit to a figure. I have not written the number of this figure. Where is this? Let us see. Yeah. So, this is figure 3.12. So, again in your book, okay. And this is a figure in which you can see the energy and you are plotting the distance or on this side. And you can see that this is defined something like this. And this is a description of how the reaction is taking place, okay. And this here is, let us say, 6 MeV, and this is R. And these distances have been measured as R prime and R. So, this is a form of radioactive decay, again the alpha particle decay. Okay. So, this is a representation of how alpha particle is emitted from the nucleus. The alpha particle has to escape a certain nuclear potential. Huh? Yes, exactly. So, it is showing the process of decay in which the alpha particle has to escape or penetrate the Coulomb potential barrier for this reaction to occur. So, this is how it can be represented graphically, and this is an example of barrier penetration in alpha decay. Okay. And then this was figure 3.12. So, you can see this in your book. And of course, you know the concept of half-life, right? So, you can use these concepts and you can calculate the various parameters and then use these in the formula, and this can be calculated. So, again this was another method that was used to calculate the radius of the nucleus. Okay. R is the radius of the nucleus, right. So, alpha decay is another method. And then there was another method that was used, and in this case they were using X-rays, the energy, they were measuring the energy of X-rays, and they were trying to determine how this can be related to the energy and the Coulomb interaction, and then they could relate that to the radius of the nucleus. But the result remains the same from all these three methods. What is the result? The result is the equation R is equal to R naught A raised to 1/3, right, where R naught is a constant, and we see the proportionality between the atomic number and the radius of the nucleus. Okay. Okay. Now, there is another heading here, which is mass and abundance of nuclei. So, when we talk about mass and abundance of nuclei, so there is a table in your book. You can open the, I can show it to you. For example, if you look at the appendix, which is C, you will see a table, you know, you remember? We have the book in soft, right, we've shared it, and you can also see it in your own, you can share it if you want. There is a table in which you can see these values. For example, this is page 832, just as you talked about cross sectional values. So, we have a table that we will be using from time to time, and for solving problems and so on. And in this, apna phone hai na aapke paas? Yes, you can open that, because if I switch this on again, then I will have to switch it off again. So, in this you can see dekha. So, what are the values, the different things that are given in this table? What can you see in this table?
I can see elements, isotopes.
You can see the various elements of the periodic table along with their isotopes and
their half-lives.
what else?
And their relative abundance or half-life.
Okay, so we are talking about abundance. Okay, so can you tell me what is the abundance of U238? Okay, 99.275%. Okay, somebody else tell me the abundance for U235. Yes. ये आप 3 चैप्टर वैसे फोटोकॉपी करवा लो, that will be useful. You know, it's better to read from the paper than from the phone. पेज नंबर क्या था इसका? 832. Have you found it? Okay, what's the abundance for U235? 0.72%. What does this mean? What do you? Let's like, I want everyone to participate. Yes. What does this mean?
It means how much it's available in our surroundings.
Yeah, like for example, where do we get uranium from? We get it from mining, right? And when we mine uranium, the ore that we get is 99% U238, whereas the useful part that we need, the useful isotope, is only 0.72%. And that's why you know that when you need to do fission, you need to increase this percentage in order to in order to produce the reaction in a feasible way, right? Otherwise you cannot do it, it's too less, the quantity is too less. Okay, so that process is called enrichment, right? Okay, so there is another way that another kind of experiment that has been performed in order to measure the mass of the nuclide. So, we talked about the radius of the nucleus. We also are interested, one of the properties of the nucleus are the mass of the nucleus itself. In this table you see other quantities as well. और क्या है इस table में? What else do you see? Huh? Okay, yes, you have I, yes. Yes. That's another property of the nucleus is the parity. So, this table is giving us different values that you can use for your problem solving or.
I do have a question. It always bothers me, and it's that if those small particles, the nucleus or any other particle, like let's take the hydrogen nucleus, if it is not even a solid stuff, then how can it spin? What exactly is spin?
Okay, we will talk about spin a little later, okay. We will, that's again one of the properties of the nucleus as well.
It does have an angular momentum, we can find that out.
Yeah.
Property, but what exactly is it?
Now, spin again is a concept that's related to quantum mechanics, right? And we have the spin quantum numbers and so on and so forth. We'll come to that, okay. So, I just want to go in some order, right. So, again another thing that I just was talking about was mass of the nucleus. So, we are talking about mass and abundance. We just saw the values of abundance of different elements which is given in your table, right. So, the second thing is the mass, and there are different ways to find the mass. One of the methods of finding the mass is through the method of mass spectroscopy. Okay. So, this is a technique in which you use an instrument for measuring mass, and you make a graph which is called a spectrograph, and from this graph you can calculate the masses. Okay. And spectrometer is again, spectroscopy is the technique, spectrometer is the instrument, and spectrograph is the graph. So, the masses pass through a detecting slit and